we have seen that when we throw a ball into air, it comes back. But there are a lot of certain aspect of this motion that we can be sure of, and that's what we are learning in this video. That is, we're looking at the key features of vertical motion under gravity. The certain properties I'll explain. That will make more sense. So if I throw an object, say with 20 meter per second velocity at say 10 feet above the ground, when the object reaches the same height, of course, it will be falling downward, pointing towards the surface, but it will be with a velocity of 20 meter per second. That is, this magnitude will be the same. The speed will be the same. Okay, so if I throw an object at a particular speed, it will come down, and the point at which it was thrown, if we happen to catch at the same position, the velocity with which we threw the object, it will have the same velocity at that height. So basically these two values will be the same, provided the heights are the same. So all these are under the assumption that we have vacuum basically. Okay. Time of flight. The time it takes to reach the top, it will be equal to the time it falls. Again, if there is no air and all of that, basically vacuum. So if it goes up for say 10 seconds, it takes 10 seconds to reach the top. It will take 10 seconds to reach the bottom, or to the same height at least. Okay, so time of flight is equal, provided the height is same. Velocity at a maximum height. So at the peak, right, it has reached this peak. The velocity at this point will be 0 meter per second. Okay guys, so please understand that everything we are talking, the first 2 points, I want to make it very clear that all these are on the same height. So if it takes 10 seconds to move from point A to B, it takes the same amount when it moves from D to E. Time it takes for the object to fall from D to E, it will be same as the time it took for the object to move from A to B. Okay, that's one thing. Then acceleration of the object is constant and equal to the acceleration due to gravity acting downward throughout the entire motion. This is applicable to objects which we throw around, not rockets and all of that. So again, this particular topic we'll be studying in detail. For now, assumption is that we are dealing with objects which are thrown from a certain height, building, or we throw it with hand or something. It's just that. So for those conditions, all of this holds good. Velocity at any height for a given height during its journey, the magnitude of the upward velocity is equal to the magnitude of the downward velocity at the same height. Okay, so let me make all of this clear by considering an object thrown upwards. So you can see the height over here, velocity over here. So we are throwing an object from this point. So it's thrown up straight. So it's slowly moving up. And within 2 seconds, it has reached the top. And now the velocity you can see at the peak, it is 0. Obviously, if the velocity is 0, it has to stop over there, right? So because there is a gravitational pull, it will start falling back. So it got decelerated. Now it is accelerating towards the gravity. So you can see that now the velocity is minus 20 and the height is the same. This is the height which it was thrown at. So it was thrown at 20 meter per second, but in upward direction. Now it has come back to the same point, but with the same velocity, opposite direction. But in terms of magnitude, it's the same velocity or the same speed. Let me put it this way. The speed is same in both the cases. Right? And let me finish the simulation. Now, there's a key point over here. If I consider a height of 30, so you can see there are 2 points. One is this and one is this. or let me consider the height of 20. That will be better. So 20, it's over here and it's over here. So corresponding velocity over here is 20. Okay, the height is 20, velocity is also 20. At 4 seconds, the velocity is how much? See, minus 20. Right, this we already seen. So it's holds good for other points as well. So consider this height. So let me kind of zoom in. Consider this height. Consider this height, 35. Okay. So corresponding 35 is over here at 3 seconds. So let's see what's happening with the velocity at 3 seconds. So at 3 seconds, the velocity is minus 10. At 1 second, the velocity is plus 10. Can you see the magnitude are the same? The speed is the same, 10 and 10. It's so for every point, guys. It's so for every point, provided the height is the same. For example, if we take 30, what else can we take? Let me take something like this. So this is around 1.4, 2.6, 1.4 and 2.6. It's somewhere over here. 1.4, you can see the velocity is around 5 and 6. And 2.4, the velocity is around, can you see that? No, sorry, 1.4 and 2.6. So 2.6, the velocity is around, you can see that 1.4 and 2.6. Can you see that? It's bit more than, bit below minus 6. So minus 5, so it's minus 6. And here also it's the same. So how we saw that at the same height, when we throw, the speed remains the same when it goes up and comes back to the same height. It's so for every height. If here along this journey, it is 5 meters per second over here, of course in the upward direction. Here it will be, the speed will be the same with 5 meters per second, just that it's pointing downward. That's it. So for a given height, understand this, the speed remains the same. Of course, there's a lot of assumption. So one of that being, it is in vacuum. Actually, it's not a lot, just that one thing, that all of this is under vacuum. Okay, so using all of these points, I'll be making use of this in numericals. So it's important for you guys to remember all of this. Okay, so you need to pause and copy this off. Again, all of this will be learned in detail, and there's a lot of variation that also will be done in another chapter.